So we're going to go over sinusoidal functions right now, which generally means the periodic functions. And it's called a periodic because there are cycles that keep on happening, like a period. So we're going to unwrap the trig circle, and we can get potentially three shapes. So when I say sinusoidal, I don't just mean the sine function, I mean all three of the trig functions, sine, cosine, and tangent. So let's just go on into the next screen and see what I'm talking about when I say we're going to draw it out. So when you look at the general circle, I've taken a circle right here and I've placed it, and I've only separated it in pi over 6. So if you remember, we talked about dividing the circles in the first video and the second into radians. So here you notice there's a pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And we have the measurements of where they land on the circle. And if you recall, the cosine represents x and the sine represents y. So each of this is an x and a y. So when I say a half, it represents cosine, and root 3 over 2 represents sine, and it is x and y. Now, just recall that 3 over 2 in decimal form is 0.866, something like that. Obviously, the half is a 0.5. And there's the one that we did not mark, which is the pi over 4. At pi over 4, it's root 2 over 2, which is 0.7. We're not going to mark that one right now. Okay, so what I'm going to do is I'm going to transfer this onto a graph, and this will be my x-axis. And since we're going by pi over 6, I'm going to try to make equal measurements of pi over 6. So pi, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this would have been your first pi over 6. This is 2 pi over 6. You want to make sure that your increments are always spaced out at the same level of spacing, and that the numbers correspond. So if you're dealing with sixes, it's better to put everything out of 6. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi, 11 pi, and 12 pi over 6. Now, if you look at some of these, you can see that they're reducible. But because we're using only this circle, we're not looking at them in that sense. But if you remember, 2 pi over 6 is also pi over 3. This is pi over 2. This is 2 pi over 3. And this is pi. So 6 pi over 6, which is over here, literally, 6 pi over 6 is pi. 7 pi, 8 pi over 6, and all of these are reducible all the way to this one, which is 2 pi, which is right here. They didn't mark 12 pi over 6, but that's what it is. So now, I'm going to also separate this with the y-axis, which is going to be my increments. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that would be my 1. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that would be minus 1. This would be the negative 0.5 right here. 1, 2, 3, 4, 5, actually right here. And then this would be your 0.5 positive, and this would be your positive 1. Now we're going to take the sine. So we're going to call this the sine function, and then we'll do it in red. So in red, I'm going to take the sine of every single every value at the angle. So at 0, we've got a sine of 0. So I place it 0. At pi over 6, which is right here, my sine, which is the second one, is a half. So I'm just going to go over here. At 2 pi over 6, it's 0.866, which is approximately here. And at 3 pi over 6, well, we're at the 1. At 4 pi over 6, we're going back to the 0.866. At 5 pi over 6, we see that it's back to the half. And then at 6 pi over 6, which is pi, it's back at the 0. 7 pi, now we're already in the third quadrant. That means our sign is going to be negative. So do all the way to the negative. 8 pi over 6, it's going to be at negative 0.866, which is approximately here. At 9 pi over 6, we're going to the negative 1. And then here we're going back over to the root 8 root 3 over 2. At 11 pi over 6, we're going to be at the half again. And then at 12 pi over 6, we're at the 0. Now, if you notice, this makes a shape of an S. If you connect your dots like this. Not beautiful. That one kind of came out of the plate. So this is the shape of an S, and this is how I remember the sine function. Now, in this case, our S is going upwards because it's called increasing. And it could have also been seen from this perspective, and if you continued your S. So this is one cycle, one period of this circle. And that is why it's viewed in this sense, because it's a period that will keep on repeating. Now let's do the same thing, but this time with the cosine. So in cosine, I'm going to choose blue. And I'm going to start by looking at the x's. So at 0, it's 1. At pi over 6, it's root 3 over 2. So that's going to be right around here. At 2 pi over 6, it's a half. So I'm going right here. And at 3 pi over 6, we're back to the 0. And now at 4 pi over 6, we're at negative a half. So we're going down here. And at 5 pi over 6, which is right over here, we're at 0.866 negative. And then at 6 pi over 6, we're definitely back at the 1, negative 1. At 7 pi over 6, which is in the third quadrant, we're again at the negative 0.866. And then at the 8 pi over 6, we're at negative a half, so we're back up here. At 9 pi over 6, we are at the 0. At 10 pi over 6, we are at a half. Notice it's going back up. At 11 pi over 6, we're at 0.866. And at 12 pi over 6, which is 2 pi, we're back here. If you look at the shape, it's a shape of a U. I kind of call it a C upside down because that's how I remember cosine. So you see how the same circle gives me a different shape because it depends on your perspective. So that's one cycle. Now, if you look at the period, the distance between here to, let me do that with a straight line. So the distance between here to here is 2 pi. And the distance from here to here is also 2 pi. So whether you are talking about cosine or sine, your period is the same. Your period of the one cycle is equal to 2 pi. And that is what sine and cosine look like. Now, the cosine could be interpreted from an upside down space or a right side up. It depends how you look at it. So every single graph that you have could be interpreted as a sine or a cosine. Now, I'll just show you what tangent looks like on the same graph. We'll do that in a different color. We'll choose, I guess, purple. So with tangent, you have to remember that tangent literally means sine over cosine. So for every single one, you take the sine over the cosine and you figure out what the answer is. Now, in order to do that, you do. For 0, it's pretty simple because at 0, 0 over 1 is still 0. So you have your first dot. At pi over 6, 1/2 over root 3 over 2. You could do this on the calculator, or you could literally say 1/2 divided by root 3 over 2, which becomes 1/2 times 2 over root 3. And these two cancel out, and that becomes 1 over root 3. Now, if you want to know what that is in terms of values, you just hit the calculator, or you do 1 divided by 3 square rooted, and you get an error apparently. Let me get the actual number. So tan of 30 is 0.57. So it would have been around here, let's say. And then you do at 2 pi over 6. And at 2 pi over 6, you have I'm having problems pausing. So at 2 pi over 6, which is 90 degrees, the tan of 90 degrees, not 90 degrees, at 2 pi over 6 is 60. So it's the tan of 60 is 1.73. So actually I don't have space for that because it's pretty high up, but it would be up there somewhere up there. And then if you go to 3 pi over 6, at 3 pi over 6, I'll just write that down here, which is over here. If you do sine over cosine, it's 1 over 0. And if you do 1 over 0, that's an error. So what do you do every time you have an error? You literally make what is called an asymptote, just like we did with the rational functions. So at this stage, we have what is called an asymptote. And this happens at every single level where it's 1 over 0. So again, it will happen at 9 pi over 6, which is over here. That was a little crooked, so let's just put it over here. Not even that's crooked. Somewhere like that. There. So basically, you have, when you're doing your tan, it will end up looking something like this shape. And that's what the tan functions looks like. So now we're going to go into another video where we're going to explain what happens when you analyze each one. So we're going to do the sine, the cosine, and the tangent. All right, part 2 coming up.